we started with the testing of hypothesis, and I guess we went over uh, one just the first page. It's only about 4 pages. Yeah. Right. All right. So let's see the problem number 3. Problem number 3. Right. So the children learn to walk less than 15 minutes. So that is the keyword, and that's going to be the claim. So that's what is going to be tested. So, all right, that itself is appearing in your question as a in your problem as a question. Okay, all right. So the sample of n is equal to 40 children form. So the sample is going to give you the constant that's called as the sample mean, which is x bar, and that's what I call it as a statistic. You have to remember what is a parameter and what is a statistic. Again, I'm telling you, any numerical value coming from the population is called as the parameter. P and T, population parameter. So P and T, that way you can remember. And then any numerical value coming from a sample is called as a statistic. So sample, S stands for sample, S stands for statistic. So the 40 sample size is going to give you the mean, which is 13.2, all right. So the population of all US children has age mu until they begin to walk, and standard deviation, some number, sigma. It's not given in the problem, that's okay. Let's see the question. Which of the following is going to be your null and the alternate hypothesis? So the null hypothesis is going to be, you are given 4 choices. Obviously, the 4th one is going to be the correct choice. I guess you are all agreeing with me, because the null hypothesis is mu equal to mu sub 0. The mu sub 0 value is directly not coming from your question, but from your alternate hypothesis given in your problem. You can say that your mu sub 0 value is going to be 15. Sometimes your mu sub 0 value is going to be given in the question. Sometimes it will not be given directly, but that you can get it from your selection of the alternate hypothesis. So my mu sub 0 value is 15, and my alternate hypothesis is going to be mu less than 15, and that is what is going to be tested, and that is my claim, and I'm going to give the special name, which is my Lafayette test. All right. So my option is going to be D, and these are all ruled out, not these ones. So that's how I'm going to be eliminating the other options. In a test of hypothesis, when do you say it is statistically significant? I guess you remember the notes that I showed it to you yesterday. In my class notes, I have the material where I'm just going to open that again. All right. So here it is. So in my notes, that is given. What I mean by statistically significant is smaller the p-value or rare event. If it is going to be rarely happening, or if it is less likely to happen with a smaller p-value, that's what we call it as a statistically significant. That's the technical term that we are using here. So the observed effect is so large that would rarely occur by chance is called statistically significant, which is nothing but the rare event. The rare event is going to give you a less likely probability value, which is going to be lesser than alpha. That means it's going to be falling in the rejection zone. That means your sample data is not going to provide enough evidence to accept the null hypothesis, because your p-value is falling in the rejection zone. You are going to eventually reject your null hypothesis. So this is the definition of your statistically significant. So recall that this is given in your class material. So based on this message, I am going to answer the question. So that's going to be smaller the p-value. Right. So I am going to say that smaller the p-value, I'm going to be rejecting. So I'm not doing any z-score because my sigma is not given, sigma is unknown. I'm going to answer just the questions based on the given problem. So the problem is asking me what is the null versus alternative. Yes, I can do that. And the next one is they're asking me what is the definition of statistically significant. And that is going to be the option C, smaller the p-value. Right? P-value is less than alpha. I'm going to be calling it as statistically significant. So the rest of the options are ruled out. All right, let's see the fourth one. Okay, so the fourth problem is the level of calcium in the blood of healthy young adults is said to follow normal distribution, but mu is 10 mg and standard deviation. Yes, here the standard deviation is given. And then from that population, you are picking one sample of n is equal to 25, and those 25 observation is giving you the sample mean, which is x bar equal to 9.6. So you have the population number, which is 10, and then you are given the sigma value, which is 0.4, and then you have the sample taken from the population of 25 measurements, and that's giving you the sample mean, which is a 9.6. So now you are going to work on the following questions. Okay, so what is the null? Oh, there is one more thing. So you are going to see, is there any evidence that the mean calcium level in the population from which these women come is less than 10? So I see the keyword less than 10, and that's going to help me to construct my alternate hypothesis. So mu equal to 10, mu sub 0, right, versus one of the alternative. It could be less than or greater than or not equal to, not all the three. It could be one of the three alternatives. Either it's going to be less or greater or not equal to. But because of the keyword less than 10, my alternate hypothesis is less than 10. And that's what is going to be tested. I'm going to look evidences for that statement. So that's going to be the claim. So that's why I have highlighted which one is going to be my claim. My claim is not the null hypothesis. My claim is going to be the alternate hypothesis. And that alternate hypothesis with less than sign is going to be left tail test. All right. So now by hand, I'm going to do my z-score. So the z-score is going to be 9.6 minus 10. Remember the z-score formula, x bar minus mu over sigma over square root of n. So I'm writing one more time here, x bar minus mu over sigma over square root of n. This is the application of your central limit theorem, or I can also write it as x bar minus mu multiplied by square root of n over sigma. So this is the z-score, right? So I'm just plugging in the value of x bar 9.6 minus 10 times the square root of 25 over sigma, which is 0.4. So my z-score value is a negative 5. What is the meaning? Look at that. This is a very, very interesting thing. Your center is mu is equal to 10, and your observation, the sample data is giving you the sample mean, and that sample mean is just about 0.4 below the center. But look at the numerical value, 9.6 is giving you the z-score value, which is about 5 standard deviations below the center. So now you need to understand how the z-score is coming into the picture and how the z-score is going to be useful here. Again, your mu is 10 and the sample data is giving you 9.6. By looking at the number, you will say 9.6 is pretty close to the 10, but that 9.6 is about 5 standard deviations below the center. It is going to give you a very big z-score value. So this is what you are going to be understanding in Math 130 class, how you are going to determine the numerical value and how far it is deviated from the center. So that particular sample data is giving you the sample mean 9.6, And that 9.6 numerical value is about 5 standard deviations below the center. Within -3 to +3, you know that you have about 99.7% of the data is going to be there. Between z equal to -3 to z equal to +3, you have about 99.7% of your data is falling. So now this is way below that, which is -5, and that's going to give you a very, very less likely probability, and the probability is going to be 0.00000287. So now again I'm telling you, you have to understand the significance of z-score. How the data or the sample data or the numerical value is giving you the z-score. It is 5 standard deviations below the center. By looking at your number, it is just about 0.4 below your the center or the mu value, but the z-score, there is a big difference. All right. Now, once you get the z-score, you are going to find the probability. So I'm just filling out the blanks. So my z-score by hand, I got the number as -5. And then what is the p-value? Because this is your left tail test, my p-value is going to be normal CDF. It is going to be -8, comma -5. I hope you remember. If you want, I can write it one more time here. So my p-value is going to be p is equal to normal CDF -8, comma -5, and this is a tiny negative sign within parentheses. I hope you remember that. All right. So this is going to be my normal normal CDF, or you can call that as the p-value. So what is the p-value here? So the p-value is the number is given in scientific notation. Because you are using your scientific calculator, the number is going to be written in scientific notation. You can plug it in and you can check for yourself. So the number is going to be 2.87105 E -7. That is the number written in scientific notation. That number should be converted into the standard notation. This is your intermediate algebra material. You know how to convert your scientific notation to the standard notation. So the probability, you are going to add 6 zeros. If it is a -7, you're going to add 6 zeros after the decimal. If it is a -5, you're going to add 4 zeros. If it is a -3, you're going to add 2 zeros. So I hope you remember how the relationship between the scientific notation and standard notation works. So you are going to see that the probability is going to be a very, very less likely number for that z-score of a -5. So the diagram explains everything. So my probability is a minuscule probability, and when I compare that with my alpha, it is falling in the rejection zone. So my alpha probability, being a left tail test, is given on the left tail of the density curve, which is 5%, and my p-value is falling in the rejection zone. That means I am going to be certainly rejecting my null hypothesis. So that's what is going to be. Oops. It's coming, hang in there. All right. Yes. So based on the p-value of your test, what would you conclude? So I would say that my null hypothesis is going to be rejected. So that is the correct choice. Out of the 4 options given, I'm going to eliminate every single option except the first option. So since the p-value is less than alpha, yes, this is the reason. Since my p-value is less than alpha, I am going to be rejecting the null hypothesis. If your p-value is not given in the problem, you usually assume it as 5%, because we always keep in mind our 2 sigma limits between -2 to +2. That's what we are going to be keeping in mind, the 95% confidence level. So with the 95% confidence level, obviously that 5%, the complementing number is 5%. That's what I call it as alpha. So if your alpha is not given in the problem, you are going to be assuming it as alpha equal to 5%. But one thing you should understand, if it is going to be true at 1%, because this number is a very, very less likely number, it's going to be 2 at 1%. Even if I'm given alpha is equal to 1%, 0.1 or 1%, because my p-value is the very, very less likely number, my p-value is certainly less than alpha equal to 1%. So that is true. If it is true at 1%, certainly it means that it is going to be true at 5%. Do you agree that if that number is going to be less than 1%, if your p-value is less than 1%, certainly the p-value is going to be less than 5%. So 1% true obviously indicates it's going to be true at 5%, but not the vice versa. Right? All right. So yeah. So whether it is a 1% or 5%, since the probability value is such a minuscule number, less likely number, it is going to be true at both 1% and 5%. If it is not given in the problem, if your alpha is not given in the problem, you usually take it as 1% or 5%. 5% is the most commonly used number for alpha. Did you understand this huge question number 3? Anybody has any question?
Yeah, I understood that.
How about others? Did you understand? Now we have used everything. So we have used the null versus alternative, we have used the z-score, we have used the probability concept, and we have also compared with the p and alpha. Did you all get it?
Yeah, I'm doing pretty good. Thank you.
Yeah, all right.
Yeah, I got it.
So now this is a full question. It's full package question and it has multiple choices. You will have to pick the correct choice. Right. So next question is also going to be similar to that. But one thing here, the keyword is more than. So if I read that question, I see the keyword more than. So that is the keyword for my alternative hypothesis. So this is my keyword for alternative hypothesis. All right, so I'm going to have mu greater than mu sub 0. I'm looking evidences for this statement. So that's going to be my alternative hypothesis. And as I said, null hypothesis is always mu equal to mu sub 0. It's always going to be 5. Even if it is not directly given in the problem, you can pick the number for mu sub 0 from the alternative hypothesis. Did you all get it?
Yeah, I got that.
Yeah, even if you are not given the direct number of mu sub 0 in your problem, you can get that mu sub 0 with the help of your alternative hypothesis statement. And here you are given alpha is equal to 0.01. So if it is specified in the problem, we are going to be comparing our p-value with the alpha and we are going to write the conclusion. Okay? So again, your z-score is a huge number, right? Your z-score is a huge number because z, if it is more than 2, because negative 2 to positive 2 is middle 95%, right? So if your z-score number is a negative 3, even that is going to be kind of your rejection zone. If your z-score number is 4, that means your observation is 4 standard deviations below the center, and that's going to give you a very less likely probability, and you are going to write the conclusion. Okay. So just it is problem 4 is problem 5 is similar to the previous problem. Just see the work that we did and make sure you understood. Otherwise, I can move on to the next question. So I just got the z-score and I got the probability value. You can also plug in all the numbers into your TI and we can see the z-score value. So suppose if I'm going to be using the TI input screen, so you can do go to stat and then test, and then option number 1 which says 1 z test. So I recommend you to plug in all the numbers that we are given. So here it is the input, and then data. You're not given the data for 400 observation because you see that you have a sample of 400. You are not given the 400 observations in your data. You are given the mean of the 400 patients is 5.2. Is that right? All right. So here I'm going to be using the stats. All right. So move the cursor down. The mu sub 0 value is 5. And then you are going to plug in your sigma value. The sigma value is 0.4. So I'm just picking all the numbers from my problem. So take your TI and make sure you understood everything. Okay. Okay. And then it's asking what is the x bar value. So the x bar value is, what is that? It's going to be 5.2. So I'm just going to plug in the value 5.2. So it's going to be 5 and then 1 and then 5.2, and n is 400. N is 400. And then my alternate hypothesis is going to be greater. So it's going to be mu not equal to mu sub 0, mu less than mu sub 0, mu greater than mu sub 0. So these are all ruled out. So this is going to be cat, and then calculate. So what is the output screen? You can check the output screen. So the output screen is giving you the number mu greater than 5, which is your right tail test. And that is your claim as well, the claim that is appearing here. And then your z-score is 4. That's right. And your p-value is 3.1686035 e to the power or 10 to the power negative 5. So this is the same as how many zeros are going to be added? We're going to add 4 zeros. If it is negative 5, remember you need to add 1, 2, 3, 4, and then the number 3168035. So this is your p-value. This is the p-value. So in your exam, you don't have to spend too much time because everything is in your TI. So you need to read the problem, pick the numbers, check, plug it in, and your TI is going to give you the z value as well the p value. Okay, all right. So what is the next one? You are getting your x bar value, which is 5.2, and obviously the sample data is going to be in this. Are you all getting this?
Yeah, I got
your
that.
TI, yeah. Everybody is. I guess you're all having your TI with you, or if you are using your downloaded version, you can plug in later, and then make sure you get your input screen and then the output screen. All right. Okay. So, yeah. So the observation 5.2, just about 0.2 more than your mean value, but still look at that. It is about 4 standard deviations above the center. Just about 0.2 higher than the mean value, which is 5, but the z-score is 4 standard deviations above the center. So I guess now you understood the importance of the z-score. Does it make sense to you all? The z-score, how it is
Yeah.
going to be converted for the
Makes a lot of
given
sense.
sample, for the given numerical value, or for the given sample. This is how we are going to measure the z-score. How far that sample data is away from the center. All right, so now I guess most of the problems are going to be similar to that. Okay, so you can go over that, and once you get the idea behind behind the concept that we are discussing here in testing of hypothesis, then there is nothing. So you are going to see how far the sample data is deviated from the center. So, and then basically remember, if p value is going to be less than alpha, you are going to reject the null hypothesis, and otherwise you're going to be do not reject the null hypothesis. That means you're going to keep the null hypothesis. So we can just, next example, let's see, number 8. And if you have any question on any of the questions that we have in this worksheet, please message me, okay? And even if you have any question in your sapling learning, do not hesitate to message me. I'm happy to answer your questions today and tomorrow and on Friday as well. All right. So the next one is again, I'm telling you, reading the question is very important. You have to read the word problem. I know for some of you it's going to be pretty challenging, but every single word given in your question is important. That will help you to choose your null versus alternative. And then sometimes the x bar value will be given with the notation x bar. Sometimes it will say just the mean taken from the sample of so and so observations. So here the sample is 12 cos and x bar is 0.298, and the standard deviation is also given to be 0.05 grams per mile. And you are given a statement, the government regulations call for NOx emissions is no higher than, that means it should be less than 0.3 grams per mile. So now you are going to answer the question. So do the data provide evidence that the particular model meets the government regulations? That's right, because the government regulation should be less than 0.3. So the wordings are going to be a bit trickier here, but still, if you read twice, you will certainly get that. Okay? All right. So my null hypothesis is always going to be mu equal to 0.3, or you can say mu equal to mu sub 0 versus the alternative. So the alternative is going to be mu less than 0.3. And that is going to be the claim, and that gives me the left tail test. Okay. So now you are going to work on the z-score. So by hand, I am showing the work here using my z-score formula, which is square root of n times x bar minus mu over sigma, which is same as square root of 12 times x bar value is 0.298 minus 0.3. But that observation is about negative, or you can say 0.139 standard deviations below the center. The sample mean is equal to 0.298 is about 0.139 standard deviations below the center. We are playing with a lot of numbers, so I want you to discriminate between the x bar value and the z-score value. So this is the x bar value, and x bar value is about 1.39 standard deviations below the center. It's good because your z-score is well within -2 to +2, right? So that's my 2 sigma limits, right? My z-score is smaller. So that way my probability is going to be bigger. So smaller z-score is going to give you a bigger probability value. That way the probability is not going to be falling in the rejection zone. It is going to be falling in the acceptance zone. So I see that the probability value is -8 comma negative 0.139 because it's a left tail test and the probability is pretty strong. It is about 44.47 percentage. Since my p-value is greater than alpha, I fail to reject the null hypothesis. Since my p-value is falling in the if this is going to be my rejection zone, this is going to be my acceptance zone all the way down. So this is going to be my acceptance region. Since my probability is falling in the acceptance region, it's not falling in the rejection region. Most of the probabilities is falling in the acceptance zone. I'm going to be accepting my null hypothesis. Okay, so if it is rejected at 5%, then it's also going to be rejected at 1%. Since my p-value is pretty strong, whether I compare with alpha equal to 5% or alpha equal to 1%, my probability is pretty strong, and it's going to be most of the probability values I'm seeing it in the acceptance zone, right? That means I am going to keep my null hypothesis. I fail to reject the null hypothesis. When am I going to reject my null hypothesis? When the value is less than alpha. Smaller the p-value, tinier the p-value, I refute it. Stronger the p-value, I fail to reject the null hypothesis. So both 5% or 1%, it doesn't matter because I have a stronger probability value. All right. So now I am going to say that. So since I'm going to be keeping my null hypothesis, there is no way I'm going to reject the null hypothesis. I want to keep the null hypothesis because of the stronger probability value. So it's going to be kept. So I do not see enough evidences to reject the null hypothesis. So in simple words, you can say you're going to keep the null hypothesis. So what is going to be the conclusion? The alternative hypothesis is going to be rejected. The alternative hypothesis that mu less than 0.3 is going to be rejected. Anybody has any question?
I think I'm good.
Yeah, all the reasons. One thing you have to understand the English or the technical terms that I'm using here. Maybe that's going to be a bit confusing, but if you read it twice, thrice, it will make sense to you. The language that I'm using, fail to reject, accepting, rejecting. So all these tiny English phrases that I'm using here may be a bit confusing to you in the beginning, but if you explore more about that, then it will make sense to you. So as much as I can, I have written all the details here. So you can go over that. Again, I'm telling you, just check with me if you have any question. Okay? So the last problem that, we have few more problems. Okay, let's go one by one. Okay, so number 9. So the number 9 is typical word problem. Nothing is given. It's not a multiple choice question. I have also given a couple of problems like that. So that way you will remember the recipe. What next? What next? So that way you can remember the recipe. Okay, it's typical word problem. No multiple choice question. Okay. So here you are given a quantitative variable. The quantitative variable is certainly your credit card balance, which is going to be in dollar sign. That's right. So in a study about the undergrad students' credit card usage, it was reported that undergrad students have the mean credit. So I'm talking about all the students, entire population. So the entire population is going to give me the mean of 3173. That's right. All right, so the next sentence, sometimes you will not use all the numbers given in the problem. So let's ignore the numbers that we are not needing, we are not going to be using here. So we can totally ignore that number. If you continue to read, you will pick all the information that's related to our z-score. So if I continue to read the problem, I am going to be seeing the population standard deviation, which is 1050. That is the number that I need. So that is also coming from the population. I put that number here, and then you are going to choose your alternative hypothesis. For choosing the alternative hypothesis, I'm going to be using the keyword. What is that? Continue to increase. So this is my important keyword for choosing my alternative hypothesis. So that's why alternative hypothesis as the greater than sign. You can notice that. So somewhere in the problem, you will see the keyboard for less than or greater than or not equal to. And this is what is going to be tested. So I am going to be calling that as my claim, because if you read it, can be concluded that. So this is what is going to be answered. Again, I'm telling you, reading the problem is important. Can it be concluded that the mean credit card balance for the undergrad students continue to increase as compared to the year 2009 report? So I see the keyword increase that's going to be appearing in my alternate hypothesis. With the increased word, I'm going to call it as the right tail test, and that's what is going to be tested, or I'm looking evidences for that claim. So you can write your claim, write it as. All right. So my null hypothesis is going to be the mean credit balance, which is 3173. Alternative hypothesis is going to be continue to increase. So I'm going to be putting the greater than sign, and then what is the recipe saying? The recipe is saying the next thing you are going to get the z-score. So the sample mean, how many standard deviations above or below the center. So that's what you're going to be seeing. So I think some information is given in the problem. The sample data is about 172. I think. Oh, here it is. Okay, here it is. The continuation of the problem is appearing here. Suppose you take a sample of 172 undergrad student with the sample mean credit card balance as 3285.10. Okay, if this is going to be the number, you are going to test higher than. This is also a keyword. Higher than is the keyword for greater than. Greater than. So you're going to have the null versus alternative, and your sample mean 3285.1 is about 1.35 standard deviations above the center, and your z-score value is going to be 0.0877, and it is greater than alpha, and you are going to fail to reject. As long as the probability is stronger than or greater than alpha, you fail to reject. When are you going to reject? When the probability is much smaller value, tinier the p value, you reject your null hypothesis. But since my p value is pretty strong, it's going to be accepted. So using my TI, I'm just plugging in all the information, the number coming from the mu, and then sigma, and then the x bar value, check, plug in all the numbers. And then you have to be very choosy between the three alternatives, not equal to, less than, greater than. So for that, you have to read the problem multiple number of times, pick the alternative hypothesis, choose the alternative hypothesis in your TI, and then hit calculate, you get that. Okay? Right. Some students will have the draw. If you do that, you will get the diagram. Some students will have the higher version of your calculator will also give you the diagram. So the diagram I have posted here, that's right, here it is. But some students may be using the older version. They may not be able to get the diagram, but anyways, I have drawn the diagram here. So this is the center. The center is 3173, and my x bar value is how many standard deviations above the center? It is 1.355 standard deviations above the center. So this is the cutoff point for my X bar value, and that X bar value is about 1.355 standard deviations above the center. And my p value is pretty strong, and this is what I call it as my rejection zone. So this is my RR, rejection region. Since my probability value is pretty strong and it is going to be falling in the acceptance zone, so from here all the way down is my acceptance zone. All the way down is going to be my acceptance region. Since my probability value is pretty strong, I would not reject my null hypothesis, so I would write fail to reject the null hypothesis. So when I am keeping my null hypothesis, fail to reject is same as keeping the null hypothesis. So I am going to reject the claim. So what is the claim? The claim is going to be greater than 3,173. So I'm not seeing enough evidence to say that it is higher than 3,073. So when I'm keeping my null hypothesis, I'm going to say the conclusion about the alternate hypothesis because I'm looking evidences for the alternate hypothesis. So my question is to answer the alternate hypothesis. Do you see enough evidences? Look at that. You wish to test the claim that I can also underline here. You wish to test the claim that it has increased. Yes, it is. Yes, it is. Because with a stronger probability value, I'm keeping my null hypothesis. So when I'm keeping my null hypothesis, which is good to go, my alternative hypothesis is going to be rejected. So that's what I'm saying. Yes, there is enough evidence to reject the claim that the mean credit card balance is higher than 317. All right, are you all good? Do you understand what I mean by the testing of hypothesis problems?
Yeah, I understand you clearly.
Yeah, how about others? Some students, they will just get it so fast, and some students, because of the wordings, tricky wordings, they will find it a bit harder. But everything makes sense to you. The flow of the testing of hypothesis and the flow of the steps that we did here, does it make sense to you? You need to tell me that.
Yes,
I'm
it does.
getting only one response from one
Yep.
student. I need to know the response from other students.
Yeah, I got it too, Mrs. Bala.
Yeah.
You got it?
They're pretty good, thank you.
All right, all right. So this is it. This is it. Okay. So I have shown you the work by hand here, and I got my z-score value, and I have also shown you the work about my p-value, and then I'm comparing my p-value with the alpha, and whether I'm given my alpha as 1% or 5%. So my p-value is pretty strong when I compare it with my 5% alpha or 1% alpha. So in both the cases, I'm keeping my null hypothesis, or I can say fail to reject the null hypothesis. That means my alternative is going to be refuted. It is going to be rejected. So this is where I'm bringing my, there is enough evidence. That conclusion part should have the technical term of there is enough evidence to reject the claim that blah, 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 whatever is given in your statement. All right, so there is another problem that we have done here. So again, the problem is given and you have to carry out the test procedure. All right. So the sample data, and you are going to do the test based on the hypothesis. The keyword is it has changed. So it has changed. I have given one problem for each kind. All right. So this one is the pH level has changed. So my alternative hypothesis is going to be mu not equal to 7.4 because the number 7.4 is directly given here, which is mu equals 7.4. I'm talking about all healthy adults. So this is my population. So the number coming from the population is mu, which is 7.4. And then this is the standard deviation. So the sigma is 1.9. Mean and standard deviations are given. And then in a sample of a 31, so from that population, I'm picking a sample of 31 patients, and the mean comes out to be 8.1. So I hope you understood what I mean by the population, the rectangle, and then inside the population, there is a circle that represents my sample data. Sample data of 31 patients giving me the sample mean. All right. So I have shown the work by hand, and your z-score is about 2.0513 standard deviations above the center. When the center is 7.4, your sample data with the sample mean 8.1, that numerical value is about 2.05 standard deviations above the center. And because it is a two-tail test, remember twice normal CDF. If the z-score is positive, then positive z-score, comma, my favorite number 8. You can put any number exceeding positive 3. You can put 4, you can put 5, you can put 6, 7, 8, 9, 99, 9999. Any number of your choice can be written as your top number. Okay? So don't forget to put twice because it's a two-tail test. So since the p-value is less than alpha, the p-value is about 4%, but the probability that you are going to be comparing with is a 5% because in the problem it's given. Use 5% level of significance to test the claim that the pH level has changed after the medication or after the new medicine given to those patients. All right. So you are going to reject the null hypothesis. So again, out of the two sentences, if you are rejecting your null hypothesis, alternatively, you're going to be accepting the alternative hypothesis. So that's what I'm going to be writing with the technical term. Yes, there is enough evidence to say that. Complete with your claim. Because this is your claim. This claim is good to go. I don't care about my null hypothesis because I am rejecting the null hypothesis. Always my sentence is going to be written based on the alternative hypothesis. Make sense?
Yeah, that makes sense to me.
So here is my z-test using the TI. Check, plug in all the numbers because I'm not given the data of the 20 patients. I'm given the sample mean. So I'm going to be picking stats. Check, plug in all the information and then get the output screen. The output screen is giving you the z-score and then the p-value and then compare. The comparison of p and alpha is going to be done by you. The TA is not going to give you that. The TA will give you only the z-score and the p-value. So you are going to do the comparison of p and alpha and your conclusion is going to be written based on that. Okay. All right, let's come to the diagram. So this is the diagram. So the center is right here. The center is right here, which is going to be your mu is equal to 7.4. Because with your two-tail test, it's going to be on either side. So mu less than mu sub 0, and this is going to be mu greater than mu sub 0. So my probability is also going to be divided in my diagram. So the p-value is 0.0402. That is going to be divided to both ends, which is p over 2 because it's a two-tail test. And the same way, my alpha is also going to be shown on both ends because it's a two-tail test. Okay, so this is my rejection region. So this is my rejection region, RR. And the same way, this is my rejection region. Oh, I have already written. Why would I confuse you? It's already there. RR. Yeah. So this is going to be my alpha value. Alpha value is going to be the bottom 2.5 percentage and the top 2.5 percentage. That's going to be my alpha, the green shaded area, and my probability value is falling in the rejection zone. So the red striped ones is going to be my probability value. Since my p-value is falling in the rejection zone, and I'm going to reject my null hypothesis. So that's what is written here. Yes. So you are going to reject the null hypothesis. On the flip side, you are going to accept your alternate hypothesis. So you see everything. So the work, then using the TI, and this is how the diagram is going to be. So what is the acceptance zone? So this is going to be your acceptance region. But your probability is not falling in the acceptance zone. Your probability is the red one, and that's going to be falling in the rejection zone. Did you all get it? I need to know your feedback.
I got it. Yeah.
Okay.
Yep, I got it.
All right. All right. So everything makes sense to you. The whole lot of reasoning that I have written here for that question by hand, TI, the diagram. Because some students will not have the diagram in the TI can give you the diagram if you use the draw option. So if you use the draw option, the TI will give you the diagram. If you use the draw option, the TI will give you the, but not this detailed though. It's going to give you the blue zone, which is going to be your rejection zone. That's what your TI is going to give you. But more details are going to be shown here in my diagram. Okay, so the last problem, just about 10 minutes, and then yes. So this is another problem. Again, this one has the keyword increased. So my alternative hypothesis, I'm going to look evidences for the alternative hypothesis. The cost has increased. So I have the greater than sign, and that's what is going to be called as my right test. And then my null hypothesis is defined, and then I'm going to see how far that x bar is deviated from the center. So the sample mean is 27,690, and that sample mean is going to be deviated from the center about 1.9174 standard deviations above the center, because it is my right test. Okay. And my p-value is going to be smaller than my alpha. It is falling in the rejection zone. So this is my rejection zone. This is my rejection zone or rejection region. And alpha is going to be 0.05 because that's what is going to be done. At 5% alpha equal to 5% level of significance, you are going to be testing, and yes, my probability value is falling in the rejection zone. With the 2.7% probability, it falls in the rejection zone, so I'm going to be rejecting my null hypothesis. So if I'm rejecting my null hypothesis, my alternative is good to go. I'm rejecting my null hypothesis, so on the flip side, I would comment about my alternative hypothesis. That one is good to go. So that's why I'm using my technical way of saying there is enough evidence to conclude that blah, blah, blah. Whatever is the statement given in your problem is going to be written. Sounds good. Are you all okay with me?
Yeah, I'm following you along
Did
clearly.
you
Thank
understand the chapter 14, how the first piece of information is talking about the confidence limits on mu? The second part of the information is talking about the testing of hypothesis. In between, you have the chapter 15, and that tells you how to get the sample size when the margin of error and the standard deviation and the confidence level is given, you are going to predict how big the sample should be. Did you all get the material on chapter 14 and 15?
Yes, that's clear
Yeah,
to
I
me.
really understand it. Thank you.
Wonderful. Thank you so much. And then have a good weekend. If you have any question, please do not hesitate to check with me. I'm happy to answer all your questions, whether it is on sapling learning or anything. Okay.
Bye
All
bye.
right,
Thank you.
So see you next week, next Monday. All right. Bye-bye.
Bye.
All right, thank you.
Have a good weekend.
Thank you. You too. Bye-bye.